Hello, everybody. Welcome. I'm glad to see you all here, and I'm really glad that we have a good chunk of time to spend together. I gave this presentation once before. I've tried to incorporate a little bit of the feedback, so some of the slides might actually be out of order. That's okay if we stumble or something. And feel free to stop me. I know normally they say, oh, we'll save the questions for the end, but feel free to stop me at any time and ask a question. And we'll just go ahead and get, oh, and by the way, if you want to scan this, this is the slides, and the video will be here as well. So the previous version of this talk is right there, and then this is the one that we're doing today will be here. Okay, so what, the letter L did what? Yeah, I guess I clicked the wrong button on the clicker. What happened? Okay, so I need to. Okay, present. Okay, we good? Okay, so let me not press whatever that button was again. Okay, this doesn't work anymore. Okay, well I'll just stand by the computer. It'll be fine. No, 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 no. Right out the gate. Okay. Now will this thing work? Always technical difficulties. Anyway, so here's some useful links that you might like to have. There's the slides. There's an appendix of some things that didn't go in the slides or we're going to be skipping over, but I'll put in there later. The video itself, the Go Proverbs, the poster version, a template repo for what we're going to be showing today, and then everybody always asks what slides to use. That's the link to the slides. It's empty slides. Okay, so as stated, I'm AJ O'Neill. If you want to follow my mostly non-controversial tweets, @_beyondcode. If you want to follow my somewhat controversial live streams, YouTube, CoolAge86, Dangerous Wrong Thinker, Equal Opportunity Offender, and Technophobic Technologist Extraordinaire. And I work at savvy.legal. So if anybody in here, if you have a startup, just if your growth stage, savvy.legal is basically helps you to manage your documents that you need to share between employees, investors, etc. It's kind of your legal hub, and I, not just because I work for them, but I honestly believe it's probably best is a hard word to use, basically the only tool on the market for this. So if you have a startup or you're part of a small company, this will likely save you headaches. And then, as stated, I do Utah Node, Utah Rust, and I also live stream on Twitch. I love Go. I love Go. Go was a part of my heart that I didn't know was missing until I found it. And when I found it, I recognized it instantly. Anybody else have the same feeling in here? Oh, half the room. That's wonderful. Wonderful. Okay, so we probably won't need to spend a lot of time going over the why you should use Go or why you should do these things this way. You probably already get it. But if at any point you find this useful, entertaining, etc., consider like, sub, follow. And without further ado, hello Go. Grand tour of tooling. Okay, so we're going to cover a whirlwind of things here. We're not going to be able to go over all of it in detail. It's just kind of a smattering of a bunch of Go tooling, Go practices, standards, and de facto standards that we're going to go over. And it's everything from understanding the philosophy of Go, effective Go, installing IDE tooling, the X library, Go mod, the package structure, what the internal directory does, how Go generate works, tools.go, what that's useful for, the vendor folder, how to have multiple modules in a package, the command folder, GoDoc, some common conventions like version and help, using Go embed, goreleaser, Webby, and CGO with Zig. Actually, I'm going to cheat right now and let you know we're not actually going to get to that. But that's kind of, whoop. Okay, so why Go? We all know why Go, because it's predictable, because it's reproducible, because it's guaranteed. Go works, and we like this. You can learn it in a weekend. It has a well-defined set of ethos, the Go proverbs, and it's cross-platform to boot. So this is why Go. This is why we're here, because we love these things. And whether you are, now some of you don't necessarily, you're not bought into the cult of Go, but I'm here as a missionary to help preach to you the good gospel of Go. That starts with understanding the philosophy. So I'd recommend, because this is the path I took, before you write your first line of Go, or if you're already, all of you are already writing Go, but to look at first the Go proverbs. And I would recommend watching Rob Pike's talk on that, as well as I created this little thing in poster form that you can print out and put on your desk and use for code reviews, and just have it as Holy Scripture writ that stays with you at all times. I think it's really important to understand that philosophy, that ethos, because all of the tooling comes out of that ethos. The reason it exists is to fulfill those needs and niches. Also, I'd recommend looking at Effective Go, which is a very short online book that is written by the Go authors that also goes into a little bit more technical detail of this is what folder structure should look like. This is what package name should look like. I've known a lot of people that have had a hard time with Go because they bang their head, they kick against the pricks, continuing along with the evangelical metaphors here. They don't adopt Go, they don't learn Go, they just start writing Go. And I think Effective Go is really helpful in giving you, pretty official standards. And then also on creedsofcraftsmanship.com, that's a site that I run, and I put lots of engineering talks on there. There's several good Go talks that I'd recommend. One of them is Simplicity is Complicated, again by Rob Pike, Things I Never Use in Go, which was by Matt Ryer. He's got a couple of good talks too. So I recommend really that you learn from the masters and see if that philosophy jives with you. If it doesn't, don't kick it against the pricks. Find a language that you love. But we're here together, so So next is, let's say, we want to do our hello world. So we want to get our package main and, print hello world and go run. Everybody's gotten to this point in this room already, but there's a couple of things I wanted to point out, because in order to run the code, you have to get Go installed. And in order to get Go installed, you probably didn't know that Go has a JSON download API. So if you, as part of your tooling or your developer process or whatever, you want to be able to get the latest version of Go or get specific versions of Go, you can get the official Go. You don't have to go through a package repository or anything. You get the official Go straight from the source, consumable in JSON format for building your own tooling. And essentially, in the perfect world, what you would do, because Go is self-contained, right? It doesn't spread and sprawl across your system. It doesn't depend on system libraries. It's not going to break when you update Mac OS or when you update Windows. It's dependable. And it's dependable because it's self-contained. And so typically what you'd want to do, the ideal would be to put Go itself into your .local opt directory in your home folder, set up a couple of symlinks and update your path, and you're off to the races. You have a good installation of Go that's the way that the good Lord intended. Now, I've already done this for you. I've got a package up. What package is a strong word? It's an installer up on webinstall.dev/Golang. So if you want to use this, this does that. It gets the tarball, untars the tarball, sets your path, you're good to go. Now, why would I recommend that you do that? Why even have this in the slide? Everybody's already installed it. Oh, and then you can update or switch versions doing Webby, Golang at whatever version you want, which we don't really switch versions a lot in Go, at least I don't. But so when you go to the golang.org and you download the installer there, if you download the PKG, it follows this antiquated method of installation that Mac has, which is to sudo install it. And so it screws up some permissions. And if you've ever installed No and Go on the same system, their PKGs kind of fight against each other over who should own user local bin. And then brew is 500 megabytes. You have to install apt. Who knows if you're going to get a version that even, you're going to get a version that's 10 years old if you install from apt. And if you're in Docker, then, lucky you, because then you can just do from scratch and you can just run whatever version of Go. But so there's some problems with installing Go that, because we've all, we're past that. We don't think about it, but I just wanted to bring that up for you to, stew on. Next, IDE stuff. Very quickly, very simple, because IDE stuff is pretty much all baked in, right? You open up VS Code, it asks you a couple of questions, you click yes, 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 and again, you're pretty much off to the races. The tooling's pretty well built in. But if you happen to have Vim, and you'd like to just kind of have that quick and easy IDE setup that you could, you log into a new machine or something, Vim Essentials and Vim Go, and you've got an IDE in Vim. And if you've got VS Code, it's a little bit harder to do the remote thing, but you've got your tools there. Okay, so you get your IDE set up. That's pretty much sets up itself for very, very, very low overhead there. And then the next thing is I want to talk about GoX, the extended library, because a lot of the tools that you want to use, or hopefully that you want to use once you know about them, if you don't already, are in there. So there's, most of the packages have no scope. It's just quotes, funked, right? But then there's this stuff like golang.org/x/crypto and stuff like that. So there's basically 3 different types of extended tooling in Go. It's for, it's not just not important enough to be part of the official Go, but it's off of golang.org/x, so it's official enough, right? So things like Go Please. This is the language server. This has to be installed for your IDE to work correctly. If you don't have it installed, then you're not going to get your autocomplete and your hinting and your error messages aren't going to be correct. Go imports. If you don't have this installed, then you're not going to have, every time you just start to type a package and function, Go imports will just boop, put your import in there for you. As long as it matches something that you've imported before, it'll just get it in there for you. Then we've got GoDoc. If you write your comments in GoDoc style, you can just run GoDoc and boom, you get out the website that's the same as what you get at package.go.dev. Yeah. And then you've got some dev-util stuff. Now, I found out there's a fair number of people who don't know about all of these, but Stringer, for example. Stringer is basically allows you to have enums so that the value, or that what you type is its value. So if I had fruits and I had apples, oranges, and bananas, Stringer basically allows you to define an enum where the value of apples is the string apples, the value of bananas is the string bananas, and so on. You got stuff like GoDoc, embed. We'll talk a little bit about embed. And then you've got your special purpose libraries like I was talking about earlier, where some of these, they're just not proven enough to end up in the standard library yet, or they're too platform specific, but they may end up in the standard library. So a lot of your crypto stuff, there's internationalization in the text package. There's just a bunch of stuff. Just go to golang.org/x and kind of explore and see what you have there. But you'll see these tools that I've just talked about, as well as packages that will come in really handy if you're not familiar with them. Okay, so now we get to you're going to open your editor and you're actually going to create a program. So now we're getting to the grit of it. Go mod init. Hopefully everybody knows about go mod init at this point. I know it was kind of slow moving at first, but it's been out for several years now. But you're on go mod init and you give it something that's URL-ish. And that is how you start your own package. If you are writing Go code where you don't have a go mod init, I don't know. Is anybody not using go mod init for their packages? Okay, we can just skip right ahead then. Okay, and then go mod tidy is anybody not using go mod tidy? All right, well, y'all are all on the ball. So I think I can just kind of skip past that there. Whoops. A little bit of lag. Okay. Go right past that. Okay, we can also have, that's a slide that's out of order. Okay, so let's look at the anatomy of our project. Once we've initialized it, initially, in the simplest case, you got something like this, where your package is called hello. You're going to have your Git folder inside. If you're not aware of .ignore is kind of like .gitignore, except that it's for tooling. So, for example, if you're using ripgrep, Anything that's in .ignore will be ignored by ripgrep and other tools that respect .ignore, so it's more generic than gitignore. There might be things that you want to commit, but you don't want to search. You're going to have your go mod, your go lock, and then depending on whether you're doing a library or a binary, if you're only ever going to do a binary, which I think this is maybe short-sighted, maybe not, but if you're only ever going to do a binary, you could just have your hello.go right in your hello package directory, and that's it. I'd recommend generally just going with the command structure anyway, but if it's a library, you start, your entry point code is right here under your package directory, and then the command folder is where you can have all your different commands. So if you have 10 different commands related to this library, maybe they're examples of how to use it or whatever, you can have them under that command directory and then named what the command is going to be. So if we have a command that's going to be, probably a better name would be greet, because maybe it can say hello and goodbye or do something, somewhat interesting other than just print hello. But you name the folder that, and then you put your Go files in there, and then you can have multiple commands in the same repository, as well as the library that those commands are probably used by. Now, it gets a little bit more robust, and we're going to learn about these extra directories, but I'm going to point out assets. If you have static assets, either that you want to bundle with your web server or you want to bundle with your desktop application, it's conventional to have an assets folder, and that would be used with Go embed. Also, there's this thing called the internal folder, which if you're going to publish a library, especially in the early versions, if it's going to go in production, it should be 1.0. This is the Go way. This is the way. But there's a lot of stuff that we just don't want people to have access to. We want to say, look, this is internal implementation details. I don't want you to feel like you can be dependent on this because it's going to change. And so in addition to being able to uppercase things to make them public and lowercase things to make them private, you can also put them in the internal folder, and this will make them internal. And that means that no one else outside of your package can rely on it, but you can kind of prototype it there and figure out what you're doing, what you want, public, private, etc. You might have a migrations directory if you got a database. Tools is another pseudo-standard directory. This is for a tools package. We'll talk more about that later. And then vendoring, we'll also talk more about that later too. But you can, I think the best way to store your Go code is with all of the related code that you need for the project to be running, because Go is all about being predictable, reliable, guaranteed, right? And vendoring, which again, I'll talk more about later, but this allows us to make sure that through time and space, our Go code is going to run anywhere. All right, so we'll talk about, we already talked about hello. We already talked about internal. So like I said, it's for things that you don't want to export to other packages, but that can be used as peer within your own package. Anything that you put under there. So it is, yeah, we already talked about this. It's experimental stuff, it's unstable stuff, it's stuff that you don't want to be protected by your 1.0 guarantee. That's what internal's for. It's kind of private. All right, let's talk about Go generate. So it just makes me so sad when people talk about make and they're using Go. Make is bad because one, it's bad, and two, it's not cross-platform. You can't expect make to work reliably between Linux and Mac, and certainly not Windows. You're gonna have somebody install the entire GCC toolchain just in order to run some sort of convenience command? Please no. So Go generate does so much great stuff, but a lot of the things that people think they would use make for is really what Go generate is good for. And if you've got kind of a list of things that need to get done, rather than have a make file, you can just create a generate.go at the top level of your package, and then annotate it properly, and put the things that ought to be done as part of your generation steps. And so then you can run Go generate at the top level and have it do all the things that it needs to do, or you could have some more make-filey like scripty type things that you could put in another folder that only run when you run Go generate on that. But Go generate is our way to run build scripts in Go, among other things. So we don't want to make file, we already talked about that. It's not cross-platform, GC toolchain, blah, blah, blah. Okay, so let's talk about that tools folder for a second. So I mentioned Stringer. And Stringer's great because I don't think the API of it has ever changed since I heard about it. But there's a lot of the Go tooling that does get updated over time. So was anybody around for the switch to Go modules? All right, so about half the room, okay. So you've experienced the pain of this, at least in that, where you probably had some tooling that relied on the old way, but you're trying to transition a package to the new way, and things would get really confused about how dependencies were supposed to work and stuff like that. So your tools package allows you to identify specific versions of a thing, particularly tools, meaning things that you would run, like Stringer or like GoDoc. And what you do is you give it a build tag. You can't use ignore because the build tag ignore actually will make the thing ignored. And we don't want to ignore it. We just want it to be, we want it to be within our versioning, but outside of our building. And so you put this go build tools up at the top and call your package tools, and you can put your imports there of things that you want versioned. So again, Stringer's kind of a poor example because it's been so incredibly consistent throughout the years. But if you have any tools where you want to rely on the specific version of that command, you can list that in your tools package. It'll get locked in your go.mod and your go.lock. And then you can run that with Go generate or whatever else, and you can be guaranteed that 10 years from now, if that tool has been evolved 7 times and has a new command line options and something's been deprecated, you're going to be unaffected. You don't unaffected. You don't have to worry about whatever version was installed on your machine at that time. You can be guaranteed that whether it's going through a CI/CD deployment or you're sharing with a coworker, no matter what version they have installed locally, when they run the Go generate or any of the build or tooling process for your repository, they're going to get the version that you used that you know works. And so here's an example of how you would use that with Go generate. So you Go generate, Go run, mod vendor, which I don't think that's necessary anymore. I think that's now the default as of 118 or what, I don't even, are we at 118 or 119 right now? 119, so I'm behind the times. So I don't think you have to put that mod vendor anymore, but in some of the older versions of Go you did. And then you can just give the package, the import path to the tool that you want, and that's going to use the one that's saved in your vendor folder. And it's going to use, or if you don't have the vendor folder, anyway, it's going to use the correct version of it. So you're not going to get bumped up by that. So let's talk about that vendor folder real quick. So again, vendoring, the purpose of it, yeah, it bloats the size of your repository. Yes, because you're pulling in a duplicate copy of all the code you depend on. But this makes it predictable and reproducible and guarantees that whether it's a CI/CD environment or a coworker or a new machine, that you're going to get the exact same results every time. If somebody commits infocide and they delete all the repositories, you're not going to be affected. So whether it's stupidity or maliciousness, you don't have to worry about it. So all you got to do to have Go use vendoring is to run go mod tidy, which is going to read through all of your packages, including your tools package, and then it's going to download, well, I guess your code probably would have already been downloaded, but it's going to copy from the global location where it already downloaded it into your vendor folder in your project. And then you commit that folder, and you put that folder in your .ignore, not your .getignore, so that it gets committed to the repository, but when you do ripgrep or some such, your tooling doesn't go look through the vendor files and muck up your search results and stuff like that. All right. And again, I don't think this is necessary anymore to put the mod vendor. I think that now, if it sees the vendor folder there, this is the default behavior, but I left it there because that's what I knew at the time. But yeah, you can run go generate, and go generate will run with, if you've got your vendor folder there, it'll run with those versions of the things. And same thing with go build. So you've got more reproducibility and more guarantees. All right. So we already talked about all that. So now let's talk about having multiple modules inside of a package. The purpose of having multiple modules inside of a single repo is essentially to limit dependency hell. Has anybody used Go Migrator? Okay. Has anybody used another package that basically depends on the entire universe for its examples and tests. Yeah, so this is a sucky situation. If you are creating something that you're going to export out to others, you probably want a plethora of examples, and you probably want robust tests. And to have those great examples and those robust tests, you might have to depend on everything in the universe. With the case of Go Migrator, it depends on every possible thing that could ever be conceived of as a database. So MySQL, MS-SQL, Postgres, S3, GraphQL, something, or that's not really a database, it's protocol. I don't, but it depends on dozens and dozens of databases. And I don't want to have to vendor that. I don't want that to be in my go.mod and go.lock because I'm not using MS-SQL. I'm just using Postgres. So why do I need 17 databases in my go.mod and go.lock? I shouldn't need that. So what you can do is you can run go mod init inside of subfolders in your repository. So if you've got an examples folder in your repository, run go mod init in there. That way, when people go to import your module, the imports that they're going to get are going to be scoped to what they're actually importing, and it won't descend down into the examples folder because it'll see, oh, the examples folder has its own separate go.mod and go.lock. I don't need to go dependency lock or vendor everything that's in there because I'm not actually using that. Yeah, so we talked about that. Oh, blank slide must be the end. No, it's not. It's just, uh-oh, what's going on? Had some blank slides. Okay, then we already kind of talked about the command directory. So basically, this is a convention. This is not hard set. The vendor directory is hard set. Tooling relies on it being named vendor. I think there might be some tooling because this is a de facto standard that relies on this. But in general, you just want to put your commands under command. So anything that can be built as a binary, especially if you have multiple binaries, you just want to nest it under there, and I don't think there's anything too interesting about that. So we'll just, whoops. Oh, what? Oh no, what happened? I am not very good with this thing, as you can tell. All right, so now let's talk about GoDoc. I love GoDoc. GoDoc just, I mean, we go to, everything is automatically documented. If it's been pushed to GitHub, if anyone has ever imported it, then it's on, I always forget, is it package.go.dev or go.package.dev? But it's, it's there by default. What?
Package.go.dev sounds a lot more likely.
Yeah, so all of the documentation automatically gets there because of the power of GoDoc. So whether you use it or not, GoDoc is working for you, but use it. One thing that you can do if you want to have a space where you can have more comprehensive documentation that's got longer examples, that's got a bigger explanation, you want to keep it separate from the code, you can have a doc.go where you put kind of the meta information about the package itself, and then keep each of your files, the GoDoc in there, keep it specific to just the functions that are in that file. So that's something to know. GoDoc tricks. So this is a link here. If you just search for GoDoc tricks, this is basically a cheat sheet of all the different ways that you can use the GoDoc syntax. Because unfortunately, they didn't standardize on Markdown. They kind of created their own thing. That's the one complaint I have about GoDoc. But with the help of GoDoc tricks, you can kind of see basically everything that you see on any Go package. If you want to know how it's done, check out GoDoc tricks, and it'll have a little mini sample showing how you can replicate that type of thing. And this goes with inline runnable examples, any of the styling and formatting that's possible to do in GoDoc. You can find all that stuff there. Next thing, when you create a command, you may have noticed that the Go convention is to have a version subcommand. So you'll run, for example, Go version. Now most POSIX tools, Unix tools, have -- version or -V, but Go has this thing where subcommands are super, super popular. So if you want to do something like that, this is just kind of a little pro tip here. Oh, actually, and then we sorry, I skipped ahead. First thing we need to talk about when we talk about versions is that versions in Go are controlled by Git. So when you create a Git tag, that is your version for Go. So forget the other stuff I said until a minute, and then remember all that stuff. And oh, it skipped way too many slides there. I don't know what happened. What in the world? Okay. How did attack of the remote? Okay. So there's three main tools that you can use for keeping your versions consistent in your code, because you don't want to put your version in your Go program and then commit it and then push it. For one, then the version of the Go program won't actually match the commit that has the version in it, because you'd have to tag it and then you'd have to add it to the program, and then you'd have to push it, and then you'd have to tag it. You see, it's kind of recursive there. So there's two things you can use. One is three. One is goreleaser. This is the thing that I recommend the most. This manages publishing to GitHub releases or GitLab releases or Git releases or whatever, pretty much all of the main releases software. goreleaser will help you publish that, and goreleaser defines a pseudo standard by which you can, basically it'll just read in your Git tags, and at build time, when it builds and publishes, it'll put those tags into your Go binary as part of that process. So you don't have to worry about figuring out how to get the Git tags in there. Another one is this generator that I wrote. I think it's the best one out there, because I looked at what was available and I found it wasn't quite right. And this is compatible with goreleaser. It's called GoGitver. And this basically does a similar thing. I'm not going to talk about it too much. And this is kind of the format that you use for those. So in your program, you just define some variables, version, date, commit, and these strings will be overwritten at build time by the tooling. So by goreleaser or GoGitver or whatever. Now, Go also has its own thing for this, but I don't quite feel like it's at the level of maturity that goreleaser is. But Go does have read build info, and so you can import runtime debug, and you can use read build info to be able to print out what was the version, what was the Git hash. I don't think that this includes the date. Matt, does this include the date? Because you were using this, right? Okay. Caddy uses it, so it's good enough for Caddy. But this one I just don't find as compelling. All right. And then if you wanted to basically smash all of your bases with your version and help, because those are two commands that people just kind of, if they're not familiar, hey, this is a Go program, if they don't know it's a Go program and they don't know the Go convention, they're just using a command line tool or a service or a server, they're going to expect it to have -- version and -V. And you don't want to break expectations just to keep with, consistency with the Go ecosystem, because what you're deploying is broader than the Go ecosystem most likely. So this is just a little tidbit, just food for thought, the way that I do this. And I think I actually did trim instead of, I think I was supposed to do something else, strip. I think I typoed that. I don't remember. But you basically just check to see if the first arg is -V, or if it's version after you strip the dashes. And if so, then do the thing that people expect. And then you could do the same thing for help too. So, you could have, if it's -H, then do that. But if it's a single -help, or it's just the word help, or it's a double -help, just do the thing that people expect. Okay, yeah. Stop advancing too many slides at a time. Okay, now let's talk about embed. So, did anybody use bindata or VFSGen? Okay, again, about half the room. So the purpose of these is that if you want to be able to bring static assets into your binary so that when you deploy it, they're already there, nothing has to be downloaded, you don't have to have separate folders to say, okay, well, this is the directory for these app assets. The way to do that now is GoEmbed. And GoEmbed basically solves all of the problems that we had with gobindata and with VFSGen in doing what the Go authors always do. They figure out what the real kernel of the problem is, and then they isolate it down to where there's only about 2 options, and then you don't have to worry about all the other stuff. So, and another use case for this too would be if your tool helps create a directory. If you want to have an init subcommand, that would be another use case of this. So, you have for example, Hugo. Hugo init or Hugo create new or whatever it was, Hugo new. That would be a case where you want to use go embed because you have these assets that are in the binary and you want to be able to copy them from the virtual file system in the binary to the outside folder. Okay. And what that's going to look like is you're going to import embed, and then much like a generate tag, you're going to have an embed tag, and then it's going to have the name of the folder and then a star if it's supposed to include everything recursively. And so if I were to use this fs object here, I would use it the same way that I use os fs, and what I would have if I did a list dir is I would see HTML and assets are at the top level for this. Oops. Yeah, and so here's exactly how you would use that. So you would import your thing that has the assets. You would use the fs.open, and then you give it the path to whatever you need, and everything that's available to you in the normal file system is available here. And hopefully you've already heard about this because it's now been out for a good year or more, I think. Okay. And then, moving along, goreleaser. So who has been using goreleaser? All right, good. All right, now why don't you sell the audience on this? Why do you use goreleaser?
So I can just put my Go stuff everywhere people can install it. That's where we use it for homebrew and for releasing things on GitHub and changelog, all that stuff.
Yeah.
Automates all.
Yeah, it's an excellent tool. It just makes it really easy to cross-build for the different platforms you want to support. It can do cross-compilation with C if you need to embed SQLite or stuff like that. And I have a pretty darn good cheat sheet for at least the things that I do up on Webby. So webinstall.dev/goreleaser. You can install it that way. You can install it from their GitHub. And there's a cheat sheet of basically how to do, from just the most basic thing of, okay, let's just cross-compile this Windows, Mac, Linux, to some of the more advanced things. How do we get this on a Raspberry Pi with SQLite and some stuff like that. But it just makes it easy to get your GitHub releases populated so that people can download and use your stuff. Again, goreleaser, it just follows the Go mantra. Well, I guess this is the mantra I'm making up, but whatever. It's predictable, reproducible, it's guaranteed. I love it. And this is what a goreleaser YAML file looks like. It's pretty simple. You define what you want the binary name to be, the operating system matrix, the architecture matrix, and that Windows should use a zip file rather than using a tar file because it's Windows. So stuff like that. So that's kind of what the basic one looks like. Just so you can not be scared of it and you can go look at it on your own. And then you just basically create a file. You go to the GitHub new token. You create a file. You put your token in it under config go release or GitHub token, and that's how it has the permission to upload to GitHub. So and then like I said before, it includes the version, the git commit, the date, right in the build, just like we talked about earlier. Okay. And then the last thing, this is a tool that a buddy of mine and I have worked on. Have any of you been using Webby already? Okay, got a couple people. So this is, I hesitate to say it's an alternative to Brew because it has a completely different design, but functionally it's kind of an alternative to Brew. Webby allows people to install things in a predictable, reproducible, cross-platform, guaranteed way without cruft. And so if you have something that you want to be able to distribute widely to developers, Webby is a good way to do that because it allows them to just be able to install your tool without having to install 500 megabytes of Brew, without having to have a bunch of mental overhead because it's just webinstall.dev/name of tool. So that's my own thing, that's my own plug, but I 100% believe in it. I think it's the best tool out there for what it does. And then if this would stop skipping 10 slides at a time. Okay. All right, so I also wanted to talk about Zig. Does anybody know what Zig is? Zig is a C compiler. So it's just a better way to cross-compile C. So if you run into problems where you're trying to get some C code to work for multiple operating systems because you have to use CGO, remember, CGO is not Go, but sometimes we've got to use CGO and C. Zig is it's a C compiler and tool chain that it follows all of the Go philosophy. They even have the Zen of Zig that's similar to the Go proverbs. It's the C equivalent of Go essentially, and it makes it really, really easy when you have that problem. So I will reference. I don't have any time to talk about that. Didn't have enough time to really dig up a good succinct example, but if you do a search for Zig and CGO, if you have those cross compilation problems, or if you just have to deal with C without Go at all, there's some good articles that can help you be more effective at that. So I want to make you aware of that. If any of this was useful, consider, especially those online, sorry I haven't been able to check the chat for comments or anything, but consider like, sub, follow, and I will now open this up to Q&A. I went through that pretty fast. I'm sure some things were not familiar to at least half the people in this room. I'd love some questions. Yes, good sir.
First of all, really great talk. Really love that you covered so many things that are, even if you have done Go for a long time, I feel like you will for sure find something in this talk that you haven't heard about. I was curious about the vendoring you suggested. Do you think there are a lot of use cases where it might be good not to use vendoring?
I don't know why you wouldn't want to use vendoring other than if you depend on something like Go Migrator where it increases the size of your repo by several hundred megabytes.
We opted out of it. I used to find useful vendoring, but I also have to say it's really nice not to have the vendoring portion in pull requests anymore.
Well, I always do vendoring as a separate PR. So that's something I definitely recommend. If you do vendoring, any of your code changes, put that as one PR and then you're vendoring as a separate PR. That way it doesn't clutter up the space. Because yeah, I agree with that. You don't want to have to decide which of these 600 changed files are ones I need to review. Yeah, and there's also another potential detriment of vendoring is sometimes you get lazy and you say, oh, before I go PR to make a fix to this library, let me just go change it in the vendor folder and see if it works there. And you could forget that you changed it in the vendor folder and forget to do the PR. So that's another thing that I would say if you do vendoring, just if you take that shortcut, remember, because it's a lot easier to do that than to do the module replacement bit. Just remember to actually go make the PR and not commit the accidentally left altered vendored code. Oh, we're done? All right.
Okay. Thank you, AJ. Give him another round of applause. We do have a small break here because I need to